Hello, third grade. I hope you're doing well. We want to look at the strategy learning this week, which is breaking factors into smaller factors. And then we also want to look at, you're going to be playing around with a couple problems with perimeter and area. So we also would like to unpack that a little to help guide you as you work on your problems for this week's learning opportunity. So let's first look at 6 groups of 9. If you know 6 groups of 9 is 54, you would not even bother using the breaking factors into smaller factors. If you didn't know 6 groups of 9 is 54, let's look at what you could do. You could say that we can break it down into smaller factors. 2 times 3 is the same as 6, right? 3 times 3 is the same as 9. So if we think about this for a second, let's look what we can do. We can say 3 times 3 is 9. 9 groups of 3 is 27. And we still have the 2 left. 27 groups of 2 is 54. So that's how that strategy could be applied to 6 groups of 9. Again, if you knew 6 groups of 9 was 54, you wouldn't do it. Or if you used partial products and you actually said this, as a partial product, I know for some of us we would say, well, Mr. Harrison, I know that 6 tens is 60, and then if I took away 6, I know that would give me 54s too. That would be partial product. And again, that might be a more efficient way, so breaking factors into smaller factors may not be, the most efficient way. But let's look at 12 groups of 15. I think it becomes very efficient here. We know that 6 groups of 2 is 12. 5 groups of 3 is 15. Well, let's look at this for a second. If we use associative property, 5 times 2 is 10. 6 times 3 is 18. If I have 18 tens, that's a total of 180. So in that way, that's actually a very efficient method or strategy to solve the problem. So hopefully that gives you a little structure. Let's look at perimeter and area. Perimeter and area. What is perimeter? Isn't perimeter the distance, right? The line that goes around the outside of your object. So if this side is 3, this side must be 3. This side is 6, this side must be 6. So aren't we adding 3 plus 6 plus 3 plus 6? And we add that all up. So we know the perimeter of this object is 18 units. Now the area is the number of square units found in your object. So if we look at the area, let's break this up into number of square units. So 3 so if it's 3 by 6, the number of square units is 3 groups of 6. So we know then what? Oh wow, that's kind of wild. Look at that. The area is also 18. The difference is 18 units squared. Now, does that always happen? No, it does not always happen. That just happened to be the numbers I chose to use my example with. But I can't stress enough is really think about the number of square units as your area, to where the distance around the outside, or the fence line, if you imagine it as a fence line, your fence line of your shape. So if you put a fence around it, how much fencing would you have to buy? Well, we'd have to buy 18 units of fencing to fill in this object. Where the area would be if you wanted to buy soil, you wanted to buy mulch, you wanted to buy something you're going to put inside. It's the number of, it's what you're putting in here, and you're filling it up. That's the area. Okay? Hopefully that's helpful.